the different component of the WSN. And we said that we do have some design challenges related to the communication link and network design, some challenges related to the information processing, and some are related to the joint sensing when you put mini sensors on within the same area, and you do have communication as well and the control of those devices. These are the challenges that can be found in the WSN or the design of the WSN. And we said that the WSN also has some challenges related to security in terms of reliability and in terms of security. And we mentioned those objectives and challenges that should be at least provided in any WSN with regard to the security of such network. For the classification of attacks, we said we do have an internal attacks and external attacks. Internal, when you get hold of the devices and break those devices and get or manage to decrypt the data on those devices. And external, when you use, for instance, you attack those devices externally using, for instance, eavesdropping without being interfering directly or physically with the devices. And we said that the attacks can be also classified based on the layer we are working on. Okay, based on the attack, the techniques that is used, we can, as we mentioned, we said we can have attacks at the physical layer, data link layer, network layer, transport, and application layer. And at each layer, you do have a number of known techniques and attacks that can be issued against WSN. We started by looking at the attacks in the physical layer. Okay, we said at this layer we do have a device tampering, eavesdropping attack, jamming attack, Sybil attack, and path-based DOS. Okay, this is what we have covered last time with regard to the physical attack against WSN. In terms of the security and different types of attacks with regard to the link layer, data link layer, okay, we do have a number of attacks that can be found at this layer and can be categorized. Things that needs to be mentioned, but some attacks can be categorized at different, at more than one layer. For instance, you can find an attack that can be categorized for data link layer, and it is also categorized in the physical layer. Okay, if you do some things, for instance. Okay, this is why here we are just specifying the one that are related to that specific layer. With regard to the link layer, we do have what is known as a node outage. Node outage, like here when we do, for instance, you get access to the sensor nodes physically, okay, and stop them providing and achieving their objectives. Okay, when you stop, when you get hold of the node, okay, and you attack that node, and you stop the node, we no longer can do the functionality that it was intended to be done by that node. This time of attack is called node outage, because you have you have stopped the node doing its functionality. Okay, so this is the first attack that can be categorized under the data link layer. Now, the effect of this type of attack, as we mentioned here, it is stopping the node services. Okay, for instance, one of the service will the task that was designed to be done by that node is, for instance, to read some parameters, to read the temperature values, to read for instance the pressure. Okay, if that node has been stopped by this any type of attack, we call that attack as a node outage attack. Another type of attack that can be found at the data link layer is the collision. Collision happens when? Collision happens when you do have two messages are sent at the same time, okay, within the same frequency by two nodes. For instance, two sensors. You remember we said that they are using channels to communicate to each other. And before, normally in the normal way, before a node or any sensors or any device start sending, he has to verify whether the channel or the frequency that will be used for sending information is empty. There is no other signal. There is no other node using the same frequency. Now, what can happen in the collision attack? You will find, for instance, an attacker will create an environment collision by sending fake data on that frequency. When sending the fake data through that frequency, you will create some types of collision. The packet of, let's say, for instance, the packet of that attacker will collide with the packet of another node and will create collision. And when the collision is created in frequency or in a channel communication, it will create, let's say, a noise on that channel, and no one else of the nodes can use that channel at that moment, because they will try to listen to the channel if it is empty. It is not empty because of that collision. That means there is a noise. Okay, so they will stop starting sending their messages through that specific channel. This is what is known as a collision attack. We do have resource exhaustion. It is related to the collision, but what type of collision? Which is continuous collision. That means an attacker, will simultaneously send, for instance, continuously will send a broadcast message through the channel all the time. Okay, and each time a node or a wireless node or a sensor wants to, as we mentioned, wants to send data, he has to listen. As we mentioned last time, each time a node listens to the channel, it will exhaust some power, some energy. Okay, it's not like you are listening without providing any energy. When you try to listen, you are exhausting, you are depleting some amount of energy you do have. And because of that continuous repeated collision, all the time the channel has a noise on it. And those nodes or those sensors who want to send data, they will continuously try to listen to the channel in order, maybe at this time the channel is free, which is not the case. The channel is always busy because there is always a collision. And each time those nodes are listening to the channel to verify whether it is empty in order to, or free to send data at that time, they will find it busy because of that collision. So they will refrain from sending, and they will wait sometimes, random time. Okay, then they will listen again, and they will find the channel is busy. They will stop. They will listen. They will just refrain and stop for an amount of random time. Then they will listen again, and so on. Okay, continuous listening will deplete and exhaust the energy of those nodes. That's why we say the resource exhaustion for that traffic, or for that specific attack. Another type of attack that is categorized under data link layer is the traffic manipulation. What is meant by traffic manipulation? Here, what you do have, for instance, the attacker will transmit a packet, okay, at the same time when another user, which is a legitimate user, is sending the data. We'll send in a packet. That's why we're saying here, we talk about you do, for instance, monitor regular transmission. You verify whether a channel is someone is sending data, or sending message through that channel. Okay, and when you discover that this time someone is using the channel, what you do, you will transmit your message, which is fake message, as an attacker at the same time. And when you send the message at the same time when someone else is using that channel, what will happen, Shabab? You will have that collision. Okay, this is what we are saying here, because here we talk about the traffic manipulation. That means you have to monitor. It's monitoring transmission and adjusting the time. That means you try to define, you try to collect the right time to send your fake message or your fake messages on the same channel that someone is using it. Because if you don't monitor the channel, you might use, for instance, you might use your fake data at the time where no one is sending its data. That means you are not going to create collision. Here we talk about adjusting time. You need to collect, you need to adjust your time to the correct time when someone is sending his message. When we talk about that someone, which is the legitimate user, legitimate node, or legitimate sensors, at the same time, it is sending, you will send your data. So they will collide. You will send your data on the same channel, of course, in order just to create collision, and that data will no longer reach its destination. Okay? It is, as we mentioned, it is the, like collision attack, but you have to play on the timing. You have to send your data at the same time. Like not what we did here, for instance, collision and the resource exhaustion. When you always send, you try to fill, to make that channel busy all the time. Now, no, in traffic manipulation, you want to create a collision at the right time. And what is that right time? The collision will be created when you know that someone, legitimate node, is using the channel. That's why we said you have to monitor the transmission. You have to listen to the transmission. You have to listen to the channel in order to pick up the right time when you want to send your fake data in order to create collision. Acknowledgement spoofing is another attack. Okay, you can spoof an acknowledgement, and you just create when you heard, for instance, there is someone who sent data and is waiting for an ACK. So what you can do, you can spoof an ACK, okay, by sending a fake ACK, which is spoofed ACK, to the sender. Unfairness, here unfairness, we are talking about using, for instance, the channel. Okay, if for instance there is some priority in sending, let's say every node in an environment, or every sensor will send his data, or will use the channel in turn. Okay, let's say sensor 1 now is using the channel for specific time, then comes the turn of sensor 2, come then for specific time, and for the same thing. And sometimes you do have some priority for some sensors that needs to have priority in using the channel. So what you will do, this type of unfairness, what you will do, you will send a DOS attack with collision. And if you can see here, we do have collision and resource exhaustion attack, because you are misusing the market priority layer, where you would try, for instance, it's like you are checking the other node to have a priority of sending, and you will send your fake data in order to create that collision, and you do have that partial DOS where the others cannot send their data at the same time, at the right time, with that specific priority. Another type of attack, which is known as a sinkhole attack. When we talk about sinkhole attack, is for instance, here we talk about you place your malicious node, or your malicious attacker node, close to the base station. If you remember last time what we specified, we said that you do have in WSN, you have those nodes, and those nodes will send their collected data to the sink, to the base station, which in turn will send the data through the internet to the task manager. So in the sinkhole, what you will do, okay, to compromise the communication, you will put your node here, you put the attacker's device here, okay, and near the sink base station, okay, and all the data that will be sent by all these nodes should pass through your node, to the attacker, to the compromised node, through the malicious node or malicious device, okay, and you will create a sink. It's like you are you are taking the place, you are acting like a base station, okay. And what you can do here, you can select, for instance, when you receive data, from, for instance, game camera, CCTV, or a processor, or a smoke detector, you will do some selection. For instance, I don't want to forward the smoke detector data. I will not forward it to the base station. So I will drop it. That's why we call it sink hole. It's like you are creating a hole, hufra, and when you do some selection. Noise detector, I don't want data about the noise detector to be received by the sink or the base station. So when it comes to my malicious node, I will drop it. This is what is like a sink. Okay, CCTV camera, I will let it pass. I will pass it to the base station and so on. So this is basically what is known as a sinkhole attack in these terms of link layer attack. Another types of attack, which is impersonation. Impersonation, you are impersonating an ID of a cluster. You remember what is a cluster leader or a cluster? Anyone, Shabab, cluster?
Routers in like a specific area or something like that. Like
not routers specifically. When we talk about
like a network inside, like inside a cluster.
A network inside a cluster, and usually where we do find a cluster. Let me just I will share the Jamboard. Okay, if for instance you do have, let's say this is an area where you do have WSN, and you do have many. Okay, these are nodes, these are sensors, for instance. Okay, guys, so these are sensors. One of, let's say, the techniques in order to facilitate communication between those different nodes. Okay, I'm not going to talk about how the cluster will be created, because there are many approaches, many let's say techniques. Just for the sake of just understanding what is a cluster. So let's say consider, for instance, all the nodes that are closer by 1 meter to each other will be grouped into the same group. For instance, let's consider this is one of the group. Okay, let's say this was my criteria. All the nodes that are within 1 meter will be on the same group. Okay, and let's say I consider, for instance, these are the same group. Okay, just an example, Shababa. This is called the cluster. Okay, this one, each one of those are called the cluster. This is a cluster. It's like a grouping. Okay, this is another cluster, and this is another cluster. So these are considered as clusters within an area of WSN. So this is a wireless sensor network. Okay. Now, all the nodes that are within the same cluster, okay, the communication between them will be quicker. Okay, to communicate this node with this node will, for instance, this node will communicate with this, or this with this, because they are within the same cluster. It facilitates the communication. Now, how this cluster will communicate with the other cluster, and this cluster will communicate with this cluster until, for instance, I do have, let's say here, I do have a base station. Okay, my base station is here. Okay, this is my base station. Okay, and don't forget that base station normally, okay, it is connected to the internet. Okay, so that means all those nodes needs to send their data to the base station. One of the approach is to group nodes into groups. Okay, and within each group we are going to elect one of them to be the leader. Let's say this is the leader in red. This is the leader of this group, and this is, for instance, the leader of this group, and this is the leader of this group. Of course, as I mentioned, I'm not going to talk about how we are going to select the leaders. Usually, one of the approach you will select sometimes randomly. Sometimes some other approaches will say that we will pick up anyone who has more energy, okay, who has highest energy, will be picked up as the leader of this group. Why? Because he will continuously send the data. He will receive data by all the devices. This one will send the data to this, will send to this, will send to this, and on himself, that device will collect in data and will forward data, for instance, to the closest leader of that cluster, and by itself, for instance, this one will send the data directly to the base station. Will send it to this cluster head. On its turn, will send the data to the base station. That means within each cluster, one of the node will be elected as the leader. واضح يا شباب? This is, let's say, the idea about the clusters. Now, in terms of impersonation, you will find someone, malicious node. Okay, a malicious node will put himself, okay, inside a cluster and will pretend to be the leader of this group. This is the malicious node. Okay, he pretend to be the leader. He will say, I am the leader. I have the lie. I have when there will be election. He will send the data as having the highest energy within that group. And all those nodes, based on that information, they will consider it and they will think that he is, yes, he is our leader. So we are going to send all our data to him. Okay, and that node might play with the data received. He might change the data before forwarding that data to the next one. And of course, when you receive fake data, that means base station will receive fake data. It will send to the control and for further analysis. And the analysis will be based on the fake data and will send the wrong command. This is what is meant by impersonation. That means someone will take identity of the cluster leader and tell the other one that I am the leader of this cluster, send me your data. Okay, for instance, here we talk about, for instance, you are collecting data about the temperature, okay, and you send data. Okay, you see here, all the data is between 67 and 68. It is sent to the base station, and you will find someone, for instance, an attacker, okay, who will, instead of sending the correct data, he will send the wrong data, okay, to the base station, and the result will be drastically affected because decisions will be based on the received data, and they don't know that it is, let's say, wrong and fake data. Another type of attack, which is known as a wormholes attack. Wormholes attack, it's quicker. You do have, for instance, within the network, here, instead of using only one node as an attacker node, the attacker will create two nodes, okay? And he will put intelligently those nodes in some specific location, okay? He will create a tunnel between those two nodes. That tunnel is known, its characteristic is low latency node. That means the data is quicker. It is, let's say, a quicker way to send data between this node and this node, okay? And the other node, when they will see that there is a path that is quicker than the common path. For instance, let's say the path taken to send data from 1 to 8 is through 1, 2, 4, 6, 7, 8. This is, let's say, the default route that is used, or the default path that is used to send data from 1 to 8. But knowing, and because they will hear, there will be some exchange of information, and now those nodes will discover that no, there is another path which is quicker with low latency, is through this tunnel. So what they will do, they will just send their data to that attacker's node, okay, in, let's say, wishing that their data to be sent quickly with low latency to the destination. But at the end, the data is sent and it is received by the attackers. Okay, it's like here you are talking about false routing. It's like you are just pretending you have the highest and you have the quickest way, okay, a path from sender to destination. And but at the end, in reality, the attacker's node are or have created that tunnel in order just to lure those devices in sending their data through that tunnel, which in turn will be sent through or via the attacker's node. Okay, this is in terms of wormholes attack in data link layer. We do have in the network layer now. In the network layer, as you may know, for any communication between WS and node, there should be some collaboration between sensors. Collaboration, that means, as we mentioned, when you specify, for instance, when you want to send the data, there will be some exchange of information between those nodes. Okay, this node will choose, for instance, the path to reach the leader, or the cluster head, is through, for instance, sending data to this node, and this node will send data to this node. And to send data from one cluster to another cluster, there should be some communication between the leader, or the cluster head, that the data should go through this path, then through this path to reach the base station. All the routing information, okay, and the chosen routing path will be based on, let's say, will be at the level of the network layer. Now, if an attacker manages to send fake path to those nodes, that means there will be some types of false information, okay, and the node will send their data to the wrong, going through the wrong path. And among those types of attack that can be categorized as in the network layer, you do have false routing. In false routing, that means you are sending false information, routing information to the devices. And when they decide and take decision in which path they are going to send their data, they will find themselves that they are using false information. And in false routing, you do have three types of attacks. You do have overflowing routing table, poisoning routing table, or poisoning routing cache. They are very easy. You go to routing table and send false information with an overflow that routing table until it cannot accept a new routing table. And when you said overflowing routing table, you will overflow that routing table with a large volume of data, which is fake data. And there will be, because the routing table has a specific space in memory. So when a new data, when a new true data arrives to those nodes, it will not find a place to be added into the routing table. Okay, that means the routing table will be overflow. Another attack that is based on the false routing, poisoning the routing table. That means you will send fake data, you will modify the routing table with false information, with a false and wrong path. So the nodes, when nodes wants to send data to another node, it will base its calculation for choosing for instance, the shortest path. That calculation will be based on the false data, okay, and the wrong path will be chosen. In routing cache poisoning, that means you will poison the cache of the node, not the routing table. What is now consulting the cache and the routing table? What is the difference, Shabab? It's like when you do website, when you search for the website, the first time you are accessing website, it will be quicker, صح ولا لا? It will take time compared to the second time you access the same website.
The first time it takes longer, and the second time it becomes easier.
Why?
Because you loaded in loaded in the cache for that website.
First time you have to do calculation to find to fetch that website, but the second time you do it, you will get that website from the cache. You don't have to do calculation. In the same way, the first time, for instance, when you want to send, you choose and define what is the correct path is by looking at the routing table and calculating the shortest path through all the existing paths in the routing table. Once you get that path, you will store it in the cache. Next time you want to send the data to the same destination, you don't have to do calculation. You just go to the cache and look at what was in that cache, and you use that path. So what the attacker will do, will go and poison the cache. It will go to the cache and replace the correct data with fake data. Okay, instead of poisoning the routing table, which is one of the approaches, you go to that cache and poison the cache itself. Okay, another attack that can be categorized in this in network layer, which is a packet replication. Okay, when you receive packet, you will resend those packet, which is not a replicating packet, at a later time. Okay, in order just, for instance, to flood the routing table by replicating packets that have been extracted, or you got those packets while you were eavesdropping. Okay, and you send those data automatically, replicating the data later on, pretending to be from the genuine node. Black hole, it's like, when you talk about black hole, it's like a wormhole. Okay, but here we talk about a black hole. That means you will create a node near the base station. Okay, and anything that comes to you will be dropped. If you remember what I said previously, you will do some selection, for instance. But here we talk about black hole. That means anything that passes through the attacker node, okay, will be dropped. Of course, one condition is to put yourself near the base station in order to be able to receive everything. If you put this attacker node here, for instance, no one will use that path. So you will put yourself in the correct path where everyone's message should pass through your node, which is the attacker node, because you put yourself in a strategic position near the base station. That means everything should pass through you. So now what you will act, how you are going to act is whatever you receive, you just drop it. That's why we talk about black hole. That means you drop everything without any selection. You don't forward anything. Compare, if you do selective forwarding attack, it's not like a black hole. You will have the same thing, but you will do selection. Okay, instead of dropping everything, what you will do, you will just drop some specific packet from some specific node. You do some selection. Okay, we call it selective forwarding.
دكتور السلكتيف ما هي كأنها زي السينك هول؟
Yes, it is like a sinkhole. Yes, it is like a sinkhole.
طب what's the difference between them?
That's what I told you. I told you sometimes you do have the same attack with different name, but it is categorized under different layer. It depends on the techniques. Based on the techniques, you are going to use it. That selection, you are going to do selection based on what, for instance? For instance, if you are going to base your selection based on the IP address, that means I will put you under network layer. If you put your selection based on the content of the data, I will put you, and I will put this type of attack under, for instance, application layer, and so on. So that's why I said at the beginning, you do have some attacks with different names. They do have the same approach, but the techniques they are using, okay, the objective is the same. Okay, you are achieving the same objectives. By the way you achieve that objective is different. That's why you will be put under different, you'll be categorized under different layer with different name. Okay? Clear, Abdullah?
Clear, Doctor.
Okay, so we stop here, and next session we continue with the other type of attack that are categorized under transport layer and application layer, inshallah. Allah يعطيكم العافية شباب. So I will see you inshallah next session.